Hi, welcome to Think Academy. Today we're going to solve the problem in the grade 8 evaluation. This is teacher Vasily, and today we're going to work with bisectors and isosceles triangles. So let's go ahead and read our problem. Given the diagram, DE is perpendicular bisector of BC. Connecting CD, we have that AC is equal to DC, and measure of angle B is 25 degrees. What is the measure of angle ACD? All right, so let's go ahead and label the things that are given. So first, we're given that DE is perpendicular bisector, right? What does the bisector mean? It means that it bisects the angle, right? Splits it in half. So splits in half. Splits in half into equal halves. So that means that this angle is going to be equal to this angle. And it's perpendicular to the BC. So that means right here we're going to have a 90 degree, and right here we're going to have a 90-degree angle. All right, what else were we given? So we're given that AC is equal to DC, and measure of angle B is equal to 25 degrees. So this angle right here is 25 degrees, and we are given that AC is equal to DC. So this is equal to this. All right, perfect, perfect. So let's go ahead and recall. So we recall the bisectors. So we have a bisector, right? Perpendicular bisector. So let's recall perpendicular bisector theory. Right? It says that if we have a perpendicular bisector, right, and then there is a point on the perpendicular bisector, which is a point D in this case, then the segments connecting the endpoints of the base segment, which is in this case is BC, are equidistant, meaning that they are equal. So we're going to get that DB will be also equal to DC. So this is also going to be equal. And, right, so what does that give us? So since DB is equal to DC, that implies that triangle BCD is isosceles triangle. Okay, perfect. So what does isosceles triangle mean? By the isosceles triangle theorem, right? Let's recall this theorem. So by isosceles triangle theorem, it says that if we have an isosceles triangle, then the base angles are going to be equal. So that means measure of angle B must be equal to measure of angle DCB, which is equal to 25 degrees. So this angle right here is equal to this angle over here. This is also 25 degrees. Perfect, perfect. So now let's try to relate some of our angles to the angles of the other isosceles triangle. So let's go ahead and recall one of the theory, which is the exterior angle theory, right? What does it say? It says that the exterior angle of a triangle is equal to the sum of the two remote internal angles, right? So if we're talking about this angle right here, what would be the two remote interior angles? That would be angle B and angle DCB. So measure of angle CDA is equal to measure of angle B plus measure of angle DCB, which is equal to, so 25 plus 25 degrees is equal to 50 degrees. Perfect. So, okay, now we know, right, since the triangle ACD is a isosceles triangle, right? Since triangle ACD is isosceles triangle, that implies that by the isosceles triangle theorem, we will have that angle CDA is congruent to angle CAD. Congruent meaning that their measures are equal. So now let's use the sum of the interior angles. Okay, interior angles. Because what are we trying to find? ACD. And ACD is a part of what triangle? ACD. So this angle right here. Okay, so we're going to have that sum of interior angles of a triangle is going to be measure of angle ACD plus measure of angle CDA plus measure of angle CAD is equal to 180 degrees. So measure of angle ACD plus 50 degrees plus 50 degrees is equal to 180. So measure of angle ACD is equal to 80 degrees. So the option is C. All right. So let's go ahead and recap what we did in this problem. So we labeled all of the angles that we were given, and then we recalled a bisector theorem, which said that the segments DB and DC must be equal. Then, because they were equal, we found the isosceles triangles. So, and by isosceles triangle theorem, we found out that the base angles are equal. Then we recall the exterior angle theorem, right, which said that the exterior angles are equal to the sum of two remote interior angles. And then that gave us that since the other triangle was also, the triangle ACD is also a isosceles triangle, we were able to find by the sum of the interior angles that the measure of angle ACD is 80 degrees. And that would be it for this problem. Thank you.